Good morning everyone, I am Mr. Ish. Thank you for joining me for this video. With this specific question over here, we're taking a step backwards. It's a pre-calculus topic and you are asked to analyze this equation 60x squared plus 30y squared equals 150. There's a plus over there, there's an x squared, there's a y squared. It would look very much so like an equation of a circle, but the fact that you have these numbers over here, a coefficient exists in terms of the x and the y, and it would not be a circle, but it would certainly be an ellipse. Remember, when you're looking here at a circle, you have transverse axis. You could say in a horizontal direction, you have a transverse axis in the vertical dimension, or in any orientation, but these axes, the transverse axis in any direction is always equal. It's always the same because it's a circle. Radius is equal in all dimensions. But when you're looking at something like an ellipse, you have again the major axis, we'll call that A, you have a minor axis, we'll call that B. The A is always larger than B, and the A can never be equal to B, because then that would be an indication for a circle. Ellipse A is greater than B, you have these items here which will generate a coefficient. That coefficient generates such that you lose the relationship here of a circle, but you retain that for an ellipse. So what we're really looking here is an ellipse. So the best thing to do is divide everything by 150 all the way across. You'll have 60x squared over 150 plus. Here you'll have a 30y squared over 150 is equal to 1. You know that. Simplify these. You'll have a 2x squared over 5 plus y squared over 5 is equal to 1. This is what I'm talking about. They are coefficients. But we have 2 or 5, 1 or 5. These are coefficients, so it's an ellipse. Because you'll have two axes, transverse axes, which are not equal to each other. You have to put this in a better form. X squared over 5 over 2 plus y squared over 5 is equal to 1. Now, when you're looking at that, you're seeing a larger number in terms of the value here below y squared. You have something which looks like x squared over b squared plus y squared over a squared is equal to 1. So it's a vertically directed ellipse, vertically oriented ellipse with the major axis in the vertical dimension. A square over here is equal to 5, b square here is equal to 5 over 2, therefore a is equal to root 5 and b is equal to root 5 over root 2. You can always apply a calculator and get those, but you don't have to. You know c square is equal to a square minus b square. If you do this computation, you'll have 5 minus 5 over 2. You will have here a root 5 divided by root 2. That will be a value for C, same as B. It's an ellipse in a standard orientation simply because you have no translation here involved. You don't have something which looks like this: x minus h whole square over b square plus y minus k whole square over a squared is equal to 1. You don't have h and k involved. Your h and k over here are in origin over here as your center, because there is again no translation involved. Your vertices here are in a vertical dimension 0, comma, plus and minus a, which is root 5. Your minor axis endpoints, which are in a horizontal dimension, will be exactly the b value you see over here, root 5 over root 2. You can rationalize this if you want. Plus and minus, comma, 0. Your focal points will be everything within the vertex, within the vertices, closer to the center, but within the vertices, and again along the same line as the vertex. Both vertices in a vertical orientation will be 0, comma, plus and minus root 5 over root 2. You can do eccentricity over here is equal to c over a. Your c value here is a root 5 over root 2 over a, which is, root 5. These cancel out, and that's really a 1 over root 2. That's what you have, 1 over root 2, which is a root 2 over 2. You can verify this. This computation here is right. I did a mental shortcut over there, but it's right. E equals root 2 over 2. Your major axis segment is always 2a, which here is 2 root 5. Your minor axis segment is 2b, which here is 2 root 5 over root 2. You can simplify this if you want. This will go in here root 2 times. You'll end up having root 10. That will be your minor axis segment length. There are a bunch of other things which can be determined, but they're not the essential items. These right here are the essential items. And what remains now is to get a good graph of this. I can do the good graph of this right over here. When I do the graph of this, I know I'm looking here at a vertex which is root 5, which is a value between 2 and 3. So I'll do 3 lines. When I'm looking here at the minor axis, I have a root 5 over root 2. C and B are the same focal points, and the minor axis, root 5 divided by root 2 is a value between 1s and 2s. So I'll just do 2 lines over here. Your one vertex will be right over here and the other vertex will be here. Your minor axis will be here and here. Your focal points are the same value as B and C. They're equal. It'll be somewhere right over here. One here and one here. So combine these and you'll have your ellipse. So here's your vertex 1, here's your vertex 2, here's your focal point 1, here's your focal point 2, right at these little values here. This right here is your minor axis 1 and here is your minor axis point 2, and that's a vertically oriented ellipse having this equation right here. An ellipse in a standard form, because it's centered about the origin, having a vertical orientation. Again, this here also represents the same value over here. If you want, you can be a little slick over here and you can say it's 2x squared plus y squared is equal to 5. That can also represent the same equation as you see over here, but simplified. But this right here is your answer, this right here is your answer, that is equivalent, and your values are such. A is that, B is that, C is this, center, vertex, your vertices, your minor axis endpoints, your focal points, eccentricity, length of the major axis, length of the minor axis segments. And that's it for this particular video. Remember, coefficients are involved here, so it's an ellipse. If there are no coefficients and it's equal to some value here, the radius squared, then you know you're looking at a circle. Thank you for watching. Have a good day. Bye.